So we are wrapping up our chapter today with chapter 1, lesson 9. I'm going to use the book and I'm going to start on page 82. To complicate matters, I'm going to throw a bunch of vocabulary terms at you that really all kind of mean the same thing. There's just one or two little teeny tiny differences as where they're used. So we've been talking about things like proportionality, which means that the rate of change is the same. We've talked about that, a constant rate of change. We've talked about slope, which applies to graphs, and that the line, the straight line that's formed, changes by the same amount each time. You go up and over and up and over. So now we're going to toss in some more vocab and some more symbols for that. So we know that slope can be rise over run, or your change in y over change in x. That relationship is often called K. I don't know why they picked K. It doesn't sound like slope. It doesn't sound, I guess maybe it sounds like constant, but wrong letter. But y equals kx, this letter or whatever number would be here, that's going to be your constant rate of change. Okay, and of course it can't be 0 because that means there is no change. So for example, if you saw y equals 6x, that means that your slope is 6 over 1 to be precise. So you would go up 6 over 1, up 6 over 1, up 6 over 1. Okay, they gave us another example here of 2x. That 2 is going to be my rate of change. Now, they talk about something called direct variation. Direct variation requires proportionality, proportional, which means it must be a line, must go through 0, 0. Okay, to have direct variation, as one direction changes, the other direction changes. The same each time. Up, over, up, over, up, over. That's proportional and direct variation if it goes through 0, 0. Okay, this constant of variation, this K here, or whatever number you calculate, that's called the constant of variation, could also be known as the constant of proportionality. I don't know why there are so many different names for the same thing, right? The same thing could be called direct variation, constant of variation, constant of proportionality, constant rate of change, slope, rise over run, or K. I just counted 7 names for the exact same thing, okay? You have to remember they change by the same amount each time, and most of them need to go through 0, 0. Okay, let's look at some examples. Now, I look at this, I say, well, it does form a straight line. It does go through 0, 0. So this will have direct variation, a constant of variation, a constant of proportionality. You can have slope without it going through the origin, and we'll look at an example of that in just a moment. But this can do everything we need it to do. So you would find your points on the graph. You would say, how much do I go up and how much do I go over, and make the fraction. All right. So it looks like we're going up 2. Even though I'm going 1 box, remember that each box is really worth 2. So if I start here and here, I've gone up 2 and over 5. That makes the fraction of 2 over 5. Or if you want to divide these, that will take me to a decimal of 0.4 or 4/10. So if I was to do an equation, I could do y equals 0.4x. 0.4x, I suppose, if I wanted to be precise. Okay, so everything that we've been doing now gets wrapped into one neat little equation. All right, now let's look at an example where it is not proportional. And I know it's not proportional because it does not go through the origin. Yes, I have a constant rate of change, but I do not have direct variation. If I was to take all of these points and make a graph or make a table out of it, and then divide each one of these, remember they're not the same. Remember when we did this? Because if I do 11 divided by 1, I get 11. If I do 19 divided by 2, I don't get 11. And I do 27 divided by 3, I don't get 11. And 35 divided by 4, still not 11. Okay? So while there is slope, there is a constant rate of change because it goes up by the same amount. Because it doesn't go through 0, 0, there is no direct variation. This is not proportional. Okay? If you get nothing else out of this section except to look and see if it goes through the origin when it makes that line, that is huge. That will tell you so much about your problem. We're going to do some more tomorrow and in the coming days of how to kind of figure out what they're asking for with these. But really, I just want you to understand you need a straight line and you need to go through 0, 0 to do most of what they ask for.